guys, here we are for another episode of Math with Me. Today, hopefully it'll be a shorter video. I'm going to try to go a little faster, and you can rewind it if you need to, but at least you'll have it. Hopefully this new format is better. Please give me your feedback. The first thing we're going to talk about is something that we talked about probably in class for a little bit, is converting degrees to radians. Whenever you want to convert degrees to radians, well, all you have to do is multiply. Understand that 180 degrees is equal to pi radians. And we're going to use that to be able to multiply. If we have, let's say, 30 degrees and we want to convert 30 to radians, we'll multiply 30 times sorry, technical glitches. We'll multiply 30 times, well, we're going from degrees to radians, so we want radians on top. Pi over 180, and we get 30 pi over 180. We can simplify 30 and 180, and that'll give us pi over 6. Now, there's certain common degrees that you're going to need to know right off the bat. Like 30 degrees is pi over 6, 45 is pi over 4, 60 is pi over 3, 90 is pi over 2. The rest you can probably figure out, and we'll talk more about that in class if you have any doubt. But the most important ones are up to 90, pi over 6, pi over 4, pi over 3, and pi over 2. If you want to, that confuses you, an easy way to figure that out, you go into 180 6 times, so that's pi over 6. How many times does 45 go into 180? 4 times, so it's pi over 4. 60 goes into 180 3 times, so it's pi over 3. And obviously 90 goes twice into 180, so it's pi over 2. And those are the important ones to remember. Now, we talked about this coming up, that you're going to need to know several of the sine and cosines for the common ones as well. So you're going to need to know it right off the bat. We talked about this in class. If you're still confused, let me know, because I taught you about the shortcut. I'm not going to go into it now. The sine of 0 is 0. The sine of 30 is 1/2. The sine of 45 is square root of 2 over 2. The sine of 60 is square root of 3 over 2. And the sine of 90 is 1. The cosine of 0 is 1. The cosine of 30 is square root of 3 over 2. Whoops, I made a mistake here. It's square root of 3 over 2, not 4. I think I said 2, but who knows. Square root of 3 over 2. This is square root of 2 over 2. This is 1/2. And finally, the cosine of 90 is 0. For tangent, I have the tangent of 0 is 0. The tangent of 30 is square root of 3 over 3. The tangent of 45 is 1. The tangent of 60 is square root of 3. And this is undefined. Undefined. Okay, if you're still struggling with this, talk to me and I'll tell you what the shortcut is to come up with this instead of having to memorize it. On the IB test, it's not a bad idea to do this table whenever you get a trig question. They're very important. Okay, now, one thing that we talked about in class is when we knew the 3 different angles, I gave you like 45 degrees, and I asked you what other 3 angles have the same sine or cosine or tangent. Okay, one thing that you want to remember is this little saying: all students take calculus. Now, what does that mean? That means that all sine, cosine, and tangent, all 3 are going to be positive in the first quadrant. In the second quadrant, students, think of sine and students, Sine is the only one that is positive in the second quadrant. In the third quadrant, the only ratio that is positive is tangent. So take tangent, starts with a T. And lastly, calculus, C stands for cosine. So cosine is the only ratio that is positive here. They're all positive here: sine, tangent, and cosine. So just to give a quick example, we talked about last time, if I have an angle of 30 degrees, and I want to find what other angles in the unit circle. Hopefully I can get a good circle. Okay, maybe not so good. Well, it'll have to work for now. What other angles have the same sine or cosine or tangent as 30 degrees? Well, remember, sine deals with the y coordinate, so it's my y values. So the first two angles are easy. You have 30 in the positive direction, and in the negative direction, you're going all the way around here, which is just 30 degrees less than 360. So what other angles have the same sine as 360? I'm sorry, as sine of 30 would be the sine of negative 330. Now to figure out what other two angles there would be, I have to say, well, sine is the y value. So along this y value, what other angle would give me the same y value? Well, this would have to be 30. These two have to match. So if I want to find the other two values, I have to go from the initial side to here in both directions, in the positive direction and in the negative direction, and that'll tell us what the other angles are. So here, from here to here is 90, and another 60, or if you want to say 180 minus 30, either way is going to be the sine of 150. More technical troubles. The sine of 150, it's going to be negative. So this is going to be the sine of negative. Well, from here to here is 180. 180 plus 30 is negative 210. So just remember, all the angles, all the ratios are, I'm sorry, not the angles, all the ratios are positive in quadrant 1. Only sine is positive in quadrant 2, tangent in quadrant 3, and cosine in quadrant 4. All right, so now let's go a little bit more complicated. We're going to solve equations using trig, or the unit circle. So for here, this equation says, solve the equation for cosine x is equal to negative square root of 2 over 2 from negative pi all the way to positive pi. So we're going to go from negative 360 degrees all the way to positive 360 degrees. So the first thing you want to do, refer back to the chart that we had on the ratios and find out what angle gives me a cosine of negative square root of 2 over 2. Well, if you remember, that would be 45 degrees, or pi over 4. Now, cosine is negative on the left side, so we know that this would be on the unit circle. This angle would give me a negative cosine, and below it too, because you know all of them give me positive here, and cosine gives me positive here. So negative would be in quadrant 3 and quadrant 4. So we want to find out what are all the angles in the positive direction, one rotation. What this means here is you're going to go one rotation in the positive direction, counterclockwise, and one rotation in the negative direction, or clockwise. So from here to here, and from here to here. Those are the only two in the positives that would give me a cosine of -2/2. So to find x, I need to find what that would be there. What would that angle be? Well, if this is 45, you can say 180 minus 45, or you can say 90 plus 45. So the first angle would be 180 minus 45 is 135. And going around this way would be 180 plus 45, which would be 225 degrees. Now, if I continue going all the way around one full circle, those are the only two that are going to give me a -2/2. Now let's talk about going in the opposite direction, in the negative direction. So starting from here, one full revolution will give me 2 pi, so going in the negative direction from here to here, and from here to here, both of them would give me √2/2. So all it is a question of what angles these would be in the negative. And if I follow it, I get the same thing as I did before. 90 plus 45, or 180 minus 45, would be -135 and -225. However, one thing, notice I wrote it in degrees and they gave it to me in radians. So I can't leave it in degrees, I have to change it into radians. Now remember, 45 degrees, if you think about it, here is my 45 degrees, and each one of them is pi/4. So if I'm going this way, this is 1 pi/4, 2 pi/4, 3 pi/4. So 135 would be 3 pi/4. 225, which is from here all the way down to right there, would be pi/4, 2 pi/4, 3 pi/4, 4 pi/4, and 5 pi/4. You could also convert them using the ratio of pi over 180, multiply that by 225, and you'll still reduce it to 5 pi/4. I just think this is easier. Now going in the opposite direction, I have 1 pi/4, 2 pi/4, 3 pi/4 in the negative direction, so it would be -3 pi/4, and 1, 2, 3, 4, 5, -5 pi/4. So those are all the possible angles that are going to give you a cosine of -√2/2, which is what the question is asking. They're saying what angle or what angles are going to give you a cosine of -√2/2 going in the positive direction, 2 pi, and going in the negative direction, 2 pi, which is 1 revolution. Let's take another problem. All right, so we want to solve this equation. What angle x is going to give me a tangent of √3? There's my unit circle. Now, tangent of √3. That would be the tangent of 60 degrees. And it's positive, so tangent is positive. Remember, all students take calculus. Always remember, with these problems, there's always going to be 2 possible directions. One in the both of them in the positive direction in this case. So tangent of x, if we look back, here, where do I get square root of 3, that's at 60 degrees, or pi over 3. Now, they don't tell me whether it's A or B. They're giving me in degrees, so I'm going to do it in degrees. So this would be 60 degrees. And with tangent, it's easy because you just draw a straight line this way. And this would be 60 degrees too. So here and here would be 60 degrees. So they want to know what are the angles that will give it to me. Well, obviously the first one would be 60. From here in the positive direction, let me put that in green. In the positive direction, that's the first one, which is 60. And now here, they only want from in the positive direction, from 0 to 720 degrees. What does that mean? Well, one full revolution is 360, but they want more. They want 2 full revolutions. So going around twice, how many times are we going to hit this point and this point? So the first one going around the first time, this one would be 60, and then all the way around here, which would be 180 plus 60, or if you think about it, it's 60 and it's 180 degrees away from that. So it's 180 plus 60, which is 240. Whoops. 240. That's the second angle. Now, continuing, if I continue one more full revolution or half a revolution over here, back to here, on my second turnaround, I have 360 plus another 60. So if you add 360 plus another 360, or if you do 240 plus another 180, you're going to get 360, 420. And then one more this way. That's 180 more than this. So that would be 600 degrees. If I went all the way around, that would be another 180 here, would be 780, and it's beyond my, my confines of from 0, my parameters from 0 to 720. So the first one is 60, then 240, then 420, then 600, and that's it. Those are all the equations that are going to give you, or the angles that are going to give you a tangent of square root of 3 between 0 degrees and 720, which is 2 complete revolutions. I hope that makes sense. All right. Now this one's a little complicated because it's not telling you the sign of x, it's asking you the sign of 2x. Now later on, we're going to learn several trigonometric identities that might make this a little easier, but we don't want to think too difficult about this. This can be kind of easy if you think about it. Well, I know what angle gives me square root of 2 over 2. Now we're talking from 0 to 360, so that's one complete revolution in the positive direction. We're not even considering the negative ones, only the positive ones. So if I take a look, do you remember what angle gives me a sine of square root of 2 over 2? Well, it also gives me the cosine of square root of 2 over 2. It's the same angle, which is 45 degrees. Since they're giving to me, they're asking my answer in degrees, then I'm going to answer in degrees. If this were radians from 0 to 2 pi, then I would have to answer in radians. So I know that this would be 45 degrees. All students take calculus, so we want to know, since this is positive, I know that sine is going to be positive in quadrant 1 and in quadrant 2. So if I were to draw my circle, not bad. One full revolution around the circle would give me this point and that point. So let's figure out what those angles are. Going in the positive direction, because we're only doing positive, from here to here would be 45. And the second one from here to here would be, well, 180 minus 45, which is 135. Now, if I go all the way around, that would be 360 plus 45. That would give me 405, and that's beyond my parameters. So we're not going to go an additional go around. We're going to stay there. All right, so we know that's for x, but here we're given 2x. So we know here, one of the things that I like to do is I say, okay, 2x is equal to 45. So in other words, x, if I multiply it by 2, I'm going to get 45. So really, to just find x, I divide it by 2. I divide all the angles by 2. And I get the two angles that are going to give me a sine of 2x are going to be 22.5 and 62.5. Let me double check. 2 goes into 13, 2, 5. Oh, no. Messed up on that one. 2 goes into 13 6 times, remainder 1. 2 goes into 15 7 times, 0.5. 120, 14, 10. Yep, that's it. And that's how you come up. Now, for cosine, it would be different because remember, cosine would be positive here and here. If this would have been negative, it would have been here and here. So it all depends on what they're asking you for. And I believe that's it for today. It's a nice short lesson. Hopefully we can get some problems done in class, and I'll be there to answer your questions. Make sure you take down the notes and you bring them to class, and if you have any questions, I'll try to answer them in class. All right? Thanks.